be all about Lewis dot structures and specifically about single bonds. So make sure you open up your chemistry notebook, and if you don't have a chemistry notebook, make sure you have a blank sheet of paper out. These do need to be handwritten notes, and then keep these notes in a safe spot so that you can use this on quizzes and tests. And throughout the rest of the year, we'll build on this information. On the top of your page, put today's date in Lewis dot structures, single bonds. Make sure while you're watching this video, you pause it and take notes and do the examples. And then there are 3 practice problems at the end of the video that you must complete as well in order to get credit for this video. Make sure that all of your notes are legible, and then at the end of this video, you will submit a picture onto Google Classroom in order to get your points. And then we'll go through some of the answers next class. So the first thing we're going to do is talk about the steps for drawing Lewis dot structures for covalent compounds, and we're only going to focus on single bonds today. I'm going to give you the 4 steps that you can write down, and then we're going to talk through them. So pause the video and write these 4 steps down. Now that you've written it down, you may have noticed that, sorry, my camera is in the way. You may have noticed that it talks about the octet rule. So let's talk a minute about the octet rule. Well, you may have guessed that octet had something to do with the number 8, because if we think of octagon, for example, that is a shape with 8 sides. So the octet rule means that atoms tend to form in compounds in ways that give them 8 valence electrons. So in order to be stable, every atom wants to have 8 valence electrons around it. And we've talked in class about what valence electrons are. And then what you should have noticed from the past slide is it talked about hydrogen does not follow the octet. So hydrogen is an exception to it, and hydrogen just prefers 2 valence electrons around it. So now we're going to look at these steps and draw a Lewis dot structure for carbon tetrachloride, CCl4. So our first step is to determine the number of valence electrons. So I'm going to look at my periodic table of elements, find carbon, see that it's in period 4, or group 4, which means it has 4 valence electrons. I only have 1 carbon because there's no subscript here. So 4 valence electrons and only 1 atom means that there are 4 valence electrons coming from carbon. Next we have chlorine, and chlorine has 7 valence electrons, but I have 4 chlorine atoms because I have a 4 subscript here. So therefore I have to do 7 valence electrons times 4 atoms, which means I have 28 valence electrons from my chlorine. So I'm going to add these together and realize I have 32 total valence electrons in this molecule. So make sure you have this example written down thus far as we go on to step number 2. We need to determine the central atom. And we notice that we have the least number of carbon because we only have 1 carbon, yet we have 4 chlorines. But also, since carbon is present, automatically we know it's going to be carbon. So carbon is the central atom. So I'm going to put carbon right in the center. My next step is to join all of these atoms using single bonds. So I have 4 chlorines because I have the subscript 4 there. And then I need to add my single bonds to connect them. Single bonds we represent with just a line. And again, each of these single bonds represents 2 electrons. So thus, so far I have 2, 4, 6, 8 valence electrons showing. Moving on to step 4, I next need to add the remaining pairs of electrons to the elements until there are either no more electrons to place or no more places to put electrons. Of course, though, hydrogen will not have 8 electrons, but all of your other atoms that we look at in this class will have 8 electrons. So I rewrote that I need 32 valence electrons here. And so far I have 2, 4, 6, 8. My carbon's happy because it has 8 valence electrons around it. However, all of my chlorines only have 2 valence electrons. So I need to place 6 around each of them. So I place my electrons in pairs. So around this chlorine atom, Currently I have 2, 4, now I have 6 valence electrons, 8 valence electrons. So this chlorine is happy because it's following the octet. This next chlorine also happy because it has 8. This chlorine has 8 valence electrons now, and then my final one, you can't see it at the bottom, but it has 8 valence electrons as well. Next, I have to make sure that I've placed my 32 total valence electrons. And I can count these and see I have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. That one's hiding but 30, 32 total valence electrons. So we're good to go. And that's all the steps you need to take because I've placed all 32 electrons and all of my elements are following the octet, or all of my atoms. So that one's good. Make sure you followed these steps and have this example in your notes. Next, we're going to look at HF. So first we need to determine the number of valence electrons in the entire molecule. I have one hydrogen, which has 1 valence electron, and I have 1 fluorine atom, and that one only has 7 valence electrons. So total in this molecule, I'm going to have 8 valence electrons. Next, I need to determine the central atom. But since we only have 2 atoms, we don't have a central atom. So I just have to join these with a single bond to start with. So step number 3 is done. Join them with a single bond. And notice that this right here is representing 2 electrons. Now I need to place the rest of my electrons, and I need 8 valence electrons total. Right away I'm thinking hydrogen is happy because it already has 2 valence electrons, but fluorine has not yet got into its octet. It does not yet have 8 electrons around it. So I'm going to add the rest of my electrons. Right now it has 2 electrons, 4, 6, 8 valence electrons. We're good to go. And our final example we're going to do together is water, which is H2O. So I determine the number of valence electrons in the entire molecule. I have 2 hydrogens, each one has 1 valence electron, and I have 6 valence electrons for oxygen, but only 1 oxygen, so total I need to place 8 valence electrons. I know that oxygen is going to be my central atom because it is the element with the least amount of atoms in it. So I have 2 hydrogens but only 1 oxygen, so oxygen is going to be my central atom. Next, I join all the atoms using single bonds. So I know I'm going to have 2 hydrogen and 1 oxygen. So then I add those with single bonds. So that's step 3 is done. Going on to step 4, I know that I need to place 8 valence electrons total. Hydrogen right now, both of them are happy because they already have their 2 valence electrons. But oxygen is not yet following the octet because it only has 4 valence electrons around it. 2 electrons here, 2 electrons here, so 4. But then I need to add another pair of electrons around oxygen, and then another one. So now oxygen has 2, 4, 6, 8 valence electrons around it. It's happy. And I have 8 valence electrons total. Hydrogens are happy because they have their 2 valence electrons. Make sure you have all of these steps for H2O in your